So today's topic, my first, it is introduction for the cool roofs and cool materials in Europe, and what is the role of the European Cool Roofs Council. So the outline of the presentation includes a general context, the development and testing of new materials, assessment of energy efficiency in buildings, assessment of urban heat island mitigation, the standards and measurements, and how ECRC can contribute to that, which gives the floor to also Aphrodite Sinefa, who is going to talk more on this. So in terms of the general context, according to the European Commission, we know that buildings are responsible for the 40% of the energy consumption and 36% of CO2 emissions in the European Union. So by improving the energy efficiency in buildings, we could reduce the total EU energy consumption by 5 to 6% and lower the CO2 emissions by about 5%, and this represents one of the major challenges for Europe time. So cool roofs can help EU effectively address this. Also, we are witnessing the increased process of urbanization, also so-called the urban heat island, which contributes to increased energy consumption, leading to higher greenhouse gas emissions and discomfort for Europeans. So, what are the major challenges? Climate change patterns worldwide signals for the imminent threat of climate change. In December 2015, leaders in Paris confirmed this by agreeing to take immediate action to prevent it, which is the COP21 objective of keeping global temperature well below the 2 degrees centigrade threshold. Respectively, the European Union needs urgent and large-scale action to ease the low-carbon transition, and this can be supported by the various EU legislative schemes such as the Energy Union and the circular economy, and cool roofs can be a practical and affordable technology that represents an untapped potential for unlocking opportunities that lie in sustainable housing. So what are the benefits of cool roofs? We would like to mention them again. They improve the energy efficiency due to the reduction of the building heat gain. They improve the thermal comfort conditions in non-air conditioning buildings, and they improve the lifespan of materials. Is also a cost-effective solution that can be used in new and existing buildings. Cool roofs can save over time on summertime air conditioning expenditures in conditioned buildings, and the air conditioning can be savings can be averagely by 10 to 40%, and also they contribute to the reduction of peak electricity demand and related financial savings. Moreover, they improve the life expectancy of the roof system and reduce the expectancies of maintenance by reducing the thermal fatigue of the roof. We see here that for reference building, the surface temperature fluctuates for 22 degrees, while for the cool roofs, the surface temperature fluctuates between 8 degrees. Also, it contributes to the reduction of the urban heat islands and heat resulting air pollution and greenhouse gas emissions by minimizing increasing the heat emitted by the cities to the sky, and also mitigate the global warming by creating a negative impact radiating forcing by decreasing greenhouse gas emissions due to the reduced energy consumption. So, if we see the progress for advanced cool materials, we have a development of new materials where significant effort is put in intelligent coatings and materials that provide a desired response to some external stimulus such as temperature, light, etc., and also in understanding the aging of such materials. We see here some thermochromic coatings developed in Technical University of Crete, where it has the ability to change color based on the temperature. And we see here the transient temperature of these materials. And this is the transition temperature 45 degrees, which is very close to the surface temperature of the cool roofs and cool materials. And also we have thermochromic coatings with various filters, developed also by Technical University of Crete. And we see some results of the aging of cool materials, where in existing applications we see in the bottom here we see the cool material as exists in the initial application, while in the next two icons we see the cool materials after aging, and we measure that there is at least a 0.24 drop of the solar reflectance, and this contributes to an increase of the cooling load of 12.6 kilowatt-hours per square meter compared to the initial characterization of the cool materials. So we need to understand how these materials are operating during time. Also, we performed some microbiological analysis to see what kind of bacteria can be concentrated around the cool materials. And we see here the bacteria and fungi at 22 degrees for new and aged cool materials, respectively. So, about the assessment of the energy efficiency in buildings, we have various applications around Europe showing that cool materials can contribute not only in the southern Europe, which is the hot climatic conditions, but also in the temperate climates, for example, in the Netherlands. We have here the application of a cool roof coating in a roof in industrial building in Oss Netherlands, where we see in two pictures the various points where we measured the surface temperature, and the instrument that we measured the solar reflectance and the albedo of the surface. Here we have the infrared images using a FLIR camera before the cool application and after cool roof application, where we see that the surface temperature of the roof can be at least 58 degrees, while after the cool roof application, the surface temperature of the roof is 30 degrees. We have a significant reduction of the surface temperature of the roof. So with this, we see that there is an increase of 120% of the roof albedo by using cool roofs. There is a decrease of 73% for cooling, while there is a minor heating penalty. And for this study, we show that cool materials can be also a viable solution for temperate climatic conditions and for industrial buildings, where usually there's a significant burden in the cooling load due to machineries and production lines. And this application of cool materials can make a significant difference in the use of air conditioning, especially in mid-seasons. Now, if we see the assessment of urban heat island mitigation, there are various studies around Europe showing how cool materials or cool pavements can reduce the urban heat. There are such applications in Ceres, Florina, Agrinio, Archanes, Greece, and there is also a case study in the region of Nantes, France. In all case studies in various areas, we have a surface temperature decrease which is around 5 degrees, and we have a contribution to a reduction of greenhouse gas emissions of almost 7 kilograms per square meter of cool materials. We see here the difference in various points in the air temperature by applying before cool roofs application and after cool roofs application, where we have the air temperature of almost 1.5 to 2 degrees depending on the extent of application of cool materials. Now, for what is ECRC role in this? ECRC was founded in 2011. We started our work of 2011-2012, and on 2014 we released a product rating scheme, a way of evaluating the cool roof products versus their two main characteristics, which are the solar reflectance and infrared emittance. So the European Cool Roofs Council is a non-profit organization. It's a voluntary organization that brings value to their members by providing cool roof products to regulators, policymakers, consumers, and other stakeholders, and provides this product rating scheme, which is going to be discussed further by Aphrodite Sinefa. There is a list of the members, of the current ECRC members. So this provides a significant boost around for Europe, but is also collaborating with other organizations worldwide, such as US, Japan, Australia, Brazil, and India. And we have three main objectives: to formulate this product rating program, which is already done, to include the cool materials in the European standards and energy assessment methods, and to promote the benefits of cool materials to engineer stakeholders. So we created a uniform and credible system for rating and reporting these properties of roofing materials, which are the solar reflectance and infrared emittance, and are determined and verified through testing by European Coolers Council approved laboratories and a process of random testing of the various rated products among the various laboratories. This is an example of the first page of the product rating manual, which also has been updated now, and there are some changes now in the various texts, not significant changes, but there is a continuous update of this manual. And also, we are trying to elaborate to perform some work for the weathering and for the aging of these cool materials by identifying the climatic conditions in Europe that can be representative for the application of cool materials. And we have identified three different climatic regions, which representing the anticipated cool roof market in Europe, and is mainly in the Mediterranean, in the center of Europe, and in the temperate climates and the ocean climates, so the ocean climatic zone of UK and Atlantic region. You can see here how this product label looks like, where we show the initial solar reflectance, infrared emittance, and the solar reflectance index, initial and aging, and some promotional tools that you can find through our website, the brochure, and some case studies that already exist apart from those that are presented here in this presentation. So thank you for your attention, and you can see here the web page. I don't know if I was quick, and the floor is now back to Alexander, I hope.